Most of you have probably learned in your math classes how to solve systems of equations by using either elimination or substitution. You are told to multiply, divide, add, or subtract equations until they cancel out to the variable you want to solve for. Or you isolate one variable and plug that variable back into the equation to get the desired solution. However, most of you have probably never heard of Cramer's rule. You may be thinking, what on earth is this Cramer's rule? Is it another complex and useless method of solving I have to learn? How do I do this? Why should I do this? To answer your concerns and to put you at ease, Cramer's rule is just another way of solving systems of equations. As a student myself, I understand and sympathize with the unwillingness to take on something that seems so complicated. However, as a math whiz or math nerd as you may call it, I'm eager to share with you a method that has made my life a whole lot easier. I'm going to prove to all you skeptics and non-believers out there that Cramer's rule really is as easy and as simple as I make it out to be. Just bear with me and watch and learn as I explain the process. First, we will start off with the system of equations a1 plus b1 times y equals c1 and a2 plus b2 times y equals c2. You will need to write the equations in the augmented or expanded matrix form, and it should look something like this. To clarify, a matrix is a rectangular array of numbers arranged in rows and columns, like I just showed you. The entire rectangular array should be filled, meaning there are no blank spaces. You may be wondering, well, what do I do if there's no number in front of the coefficient, if there's missing variables? You should always assume that 1 is the coefficient of a variable without a number in front, and put 0 in place of missing variables. Remember that a coefficient is a numerical constant in which a variable is multiplied by or attached to, and that a variable is notated by letters. After you have written out the equations in the augmented matrix form, you will need to find the determinant of the coefficient matrix by using this form right here, and the equation b equals a1 times b2 minus a2 minus b1, as shown by the arrows. It is key to make sure that you get the right answer for d, because otherwise your entire solution will be wrong. You then go on to similarly solve for the determinant of the numerator in the solution of x by using this form right here, and the equation dx equals c1 times b2 minus c2 times b1. And this form for the equation dy equals a1 times c2 minus a2 minus a2 times c1 to find the determinant of the numerator in the solution of y. Now here comes the fun part. Well, I think so. This is a moment of truth where you find out whether or not you did everything correctly. You solve for x by using the equation x equals dx divided by d, and solve for y by using the equation y equals dy divided by d, and the ordered pair x, y will be the answer to the system. You will know whether or not you were successful by plugging the values you got for x and y into the original equations. If the equations yield a true statement, that is something like 36 equals 36, you should pat yourself on the back because you just solved the system correctly using Cramer's rule. If the equations yield a false statement, something like 42 equals 64, then you should go back and double check your work until you are proven successful. Now I will demonstrate for you a worked out example of the systems of equations using Cramer's rule. I will demonstrate this by using the example 3x plus 2y equals 4 and x plus y equals 4. You first start out by expanding the matrix. So 3 here is A, 2 is your B, and 4 is your C. That's A1, B2, A1, B1, and C1, and that'll be your A2, B2, and C2. Here is the expanded matrix form. Now we solve for D. You do this by using A1, B2, B1, A2, and B2, which is 3, 2, 1, and 1. Now you multiply 3 by 1 to get 3, and 2 by 1 to get 2. And that equals 1. So your d equals 1. Now we solve for dx. And you do this by expanding out the matrix, which is you use C1, C2, B1, and B2, and that's 4, 2, 4, 1. So you multiply 4 by 1 to get 4 minus 4 times 2, which is an 8, and your dx is equal to negative 4. Now you solve for dy. Expand the matrix using A1, A2, C1, C2, which is 3, 1, 4, and 4. 3 times 4 is 12, minus 4 times 1 is 4, and it's 8. So your dy is equal to 8. Now we solve for x by using dx divided by d, which is negative 4 divided by 1, and that equals negative 4. Now we solve for y using dy divided by d, which is 8 divided by 1, and that equals 8. So the answer to your system is negative 4, 8. At last, you have learned how to use Cramer's rule. Do with this information as you may. You could show off what you've just accomplished in your math classes, impress your classmates or your teachers. You could even teach others this method. Overall, I hope you learned something new today and truly understand how Cramer's rule works. Before I go, I would like to give credit to Jay Abramson, the principal lecturer at the School of Mathematical and Statistical Science at Arizona State University, Saul Kahn, founder of Khan Academy, as well as an MIT and Harvard graduate. And last but not least, Elizabeth Staple, the author of Purple Math Lessons with a master's degree in math, for their information on how to use Cramer's rule. Without them, my speech would not have made as much sense.